Okay, this video is going to cover chapter 4 in our textbook. We're still moving forward in our Java programming. So this book starts off with the idea of an algorithm. So an algorithm can be defined as a step-by-step way of doing things. It can also be defined as it's a way a repeatable way we can solve a problem. Okay, so our algorithm can include a couple of things. It can include the actions we want our program to execute. It also includes the order in which we're going to execute them. Okay, the book talks about something called pseudocode, which is a process where you just kind of say things like, have user input number, and then loop through numbers. So stuff like that. It's English-like. Okay, it's often a good place to start because one of the true things we can say about programming, if you can't solve a problem on paper, you can't solve the problem. You can't write a program to do it. Okay, so by doing the pseudocode, you can get an idea and plan out how the program goes. Okay, so the next thing the chapter talks about is the idea of control structures. So the control structures are ways that the code gets executed. And it also introduces this idea of the UML activity diagram. We've talked about the UML class diagrams. Those are the boxes with the name and the attributes up here and the methods down there. Okay, but this time we're talking about the UML activity diagrams. They work kind of like flowcharts if you've ever done those. Okay, so we have a solid dark circle to start things. We then have arrows that show the transitions. And then we have some action state like add grade to total, something like that. Then we could do something else. We could add 1 to count, and then we could transition to the end state. It's kind of a bullseye. Okay, so that's the sequence structure, which is the simplest. That's what we've been doing so far. Okay, so it turns out that there are only 3 kinds of control structures in Java, and in a lot of languages at least. Okay, the first is just the sequence, where you do line 1, line 2, line 3, and so forth. Okay, the next is going to be the selection. Okay, and then we have 3 types of those in Java we'll talk about. And then we have the iteration, which is repeating, and we have 4 types of those in Java. Okay, so the first of these selection types is going to be the single selection on an if. So we have if, and we've seen this already in the other chapter, some logical expression. This is an expression that includes an equal sign, the greater than or equal to, less than or equal to, greater than, less than, or not equal to, and it evaluates to a true or a false. Okay, so if this is true, then whatever statements that are here all execute, and we end it over there. Okay. As far as the UML activity diagram for an if statement, we'll start at our black circle. We'll go into a decision diamond. Okay, 2 possibilities. Let's say we have the grade greater than or equal to 60 will take us over to the action to print passed. Okay. The other way out here is if the grade is less than 60, which does not get to the state over here, but they both end up at the bullseye. Okay. So that's a single if grades greater than or equal to 60, print passed. Okay. So we can also have multiple things going on. Okay, we can have an if else. So if some logical condition, do the following statements. Could be a bunch of those. Close that if, do an else, open another else. more statements, as many as you need there, and close that out. Okay. So the diagram here starts from here. It goes into a diamond. In this case, it's an either or. So the condition's true, you go this way. Condition's false, you go that way. They have their own actions associated with them, but they both end up at the end, the bullseye. Okay. You can also have nested if else statements. So that's if some condition, another if some other condition. So at this point, we're inside of two ifs. Okay. Those can also have else's. When I'm programming those, I always like to do the outermost first and just kind of make up stuff for the inner stuff and then add that detail. Okay. And the big thing there is you want to make sure you're testing for all possibilities. Okay. So one of the big things there is if you're doing a greater than and a less than, remember it can be equal to as well. So you have to include all those cases if that's what you're looking for. Okay. Your if should have brackets around it unless it's just one line. So if we say if and then one statement, you're okay. But I tend to prefer if our logical condition. I like the brackets. I think it lends structure to things. Okay. The book talks about this question mark equals, like one line operator for if statements. I'm not a fan. I think it's too terse and not descriptive enough. Use it if you like, but I'm not going to ask you anything about it. Okay. The next thing the book talks about is going to be the while statements. Okay. So that's our first iteration. So with the iteration, we're going to have a while some condition is true. So if we set a variable int product equal to 3, and then we can do a while product is less than or equal to 100. Then we have our statements, however many we have. As one of those, we have to do something to move toward the terminal condition. The terminal condition is product getting to be 100. So in this case, we're going to let product equal product times 3. Okay. And the book may write that as product times 3, which that's not, there's some that, no, times equal. Product times equal 3, you can write it that way. I don't care about that shorthand. I think it confuses us at this point. Okay. But it is important that you have to somehow in here move toward this terminal condition. If not, you end up with that infinite loop that goes forever. Okay. And then there's the diagram in the book. You can look that up. It goes through the 2 diamonds to get its action diagram. Okay. And there's an example in the book on the class average. You can go through. It uses a counter controlled. Again, a counter controlled for loop is one that's going to go in a specific order. Okay. You're going to start at, so if I have a loop, I can say int c for counter is equal to 0. I can say while c is less than 100. And then down inside of here, I could say c out's the wrong language. System.out.println c, and I could say c is equal to c plus 1. Okay, that's a counter. Okay, we're going through a prescribed series of values for c. Okay, you can have nested control statements. Oh, sorry, got ahead of myself. The other thing we can do here is a sentinel controlled. And an example of that would be if you're entering grades, you may not know how many students you have. So you could say something on your prompt like enter grade and then -1 to end. So your while statement is going to be while the grade is not equal to -1 on the assumption that no student will have a grade of -1. Okay. You can do nested control statements if you want. That's certainly okay. Or you can have a loop inside of a loop. And again, work on the outermost, work your way inward. Okay. The last section in 412 on compound assignment operators, it's not needed either. I mean, we can do it the long way. It's not that long. I wouldn't worry about that. Okay. This chapter also points to in Appendix D that all of the 8 primitive data types are listed. So if you go there, you can find that out. Okay. So I think that's it for chapter 4. Okay. So I don't know how, I'm 15 minutes in. So let's go ahead and just do one video with chapter 4 and 5. I was thinking about doing it too, but we'll just do it as one. Okay. So let me do this again. Okay, get back. Okay. So then chapter 5 is going to be the second part of the control loops with logical operators. Okay. And it's going to give us some rules here when we're doing these counter-controlled iteration. Again, counter-controlled, the one like with the C that goes up by 1, you know the path it's going to take. Okay. So these are going to need a couple of parts. We're going to need some control variable. That's a C in my example over here. C is our control variable. Okay. You have to have an initial condition of that control variable. Okay. Again, our initial condition is going to be right here, a semicolon there. That's the initial condition. Okay. You have to have an increment every time through to make sure that it's moving in towards your termination. Okay. And then you finally have to have your loop continuation condition. Okay. So this will take the values, C being, start off being 1, 2, 3, all the way. Let's look what happens at the end. Okay. It's contingent upon C being less than 100. So when we get to 99, print out 99 here, we go to this line, C is now equal to 100. It comes back to here. This stops, so it's going to move back to the next line after that. So this case would not print 100. A less than or equal to would print 100. Okay. So there's a shorthand way we can do this, or a specialized loop called a for loop that does the same thing our while loop does. Okay. If you're worried your brain in this pandemic year just can't handle anything else, you never have to do a for loop. There are times it's more efficient, but you never have to. What it does, it combines the features of a counter control while loop. Okay. So for example, I could say the following. I could say for, and I can go ahead and do my control variable declaration in here. So I int counter is equal to 1. I'm going to go ahead and put in my terminal condition, or my condition to continue. So I'm going to keep continuing as long as counter less than or equal to 10. And then I'm going to have what happens of my counter plus plus, which is the same thing as counter is equal to counter plus 1. Okay. And then you have whatever statements that you have, which ends here. Okay. You have to be careful here, again, like we were just saying with the 100, with the off by 1 error, which is common in programming. I had one today in my C++ class. So a way to think about the issue, let's say that you've got to make 100 feet of fence, and you're going to put fence posts every 10 feet. How many fence posts do you have? Most people, their gut feel is that you have 10 fence posts. That's incorrect. You have 11 fence posts. You're not including the first one. Okay. So it's the same way here. You've got to make sure that this symbol here, that it is what you think it is, that you're including what you want to include. Again, this one's going to go 1, 2, all the way to 10 because of less than or equal to. And you can't really write it that way, of course. It's going to be less than or equal to in that way. Okay. If I just a less than, it would only go up to 9. Okay. So that's the off by 1 error to avoid. There's a good example in the book on page 172 on compound interest. It also gives some enhanced formatting things that you can do. Okay. A couple of other structures we're going to hit. There's a do while. So when we have our while, let's go back to our while. With our while loop, there's no guarantee that this line will ever be executed. Okay. If we were to say, for example, C is equal to 1000. This is never true. This never executes. Okay. So it doesn't always happen. We have to make sure our initial condition is right. With a do while loop, it's going to make sure that it always happens at least once. So with that, we do a do, nothing else, open our bracket, whatever statements that we have. And then we're going to, at the end, have a while with some logical condition. Okay. So the test happens after it runs one time. Otherwise, it works exactly the same. You don't ever have to use these. Sometimes it's more convenient. I tend not to very often. Okay. Another kind of control structure here, I think the last one we have, is the switch. Now, C++ has a switch, but Python does not. So this is going to be kind of new. So what switch does, it allows you to do multiple cases of a variable. It's like a bunch of if statements. Again, you can always just do a bunch of if statements if you want. But in this case, the syntax looks like this. We start with a switch on some value. In this case, we're going to take a grade and divide by 10. So it's going to calculate that value. Okay. We're then going to go through and do a bunch of cases with the word case. So we're going to start with case 9. If it's 9 or 10, okay, so if case 9, by default, it's going to go to whichever one is correct. So if it's a 9, it's going to go here. It's going to go until it hits a break. Okay, so I'm going to say case 9. I'm going to say case 10 are going to be the same thing. Again, those are colons, not semicolons. Okay, then let's say here I'm going to do a plus plus on the A count. So now that's another A. Okay. Then to keep it from breaking or going any further, I have to put a break. The break will send it to the end of the case. Okay. And then I can do a case on an 8 plus B count, another break. Okay. So when this value is determined up here, so we're going to take whatever the grade is, divide by 10. This is an integer division, so it's going to be a whole number. Okay. We're going to look to see if it's a 9 or a 10, it will execute this line of code, hit this break, and go all the way down to the end of the switch. Okay. If not, it will keep flowing down past the rest of this. So if this is not true, it's going to skip to here. And if it's 8, this will be true, hits the break, again, goes all the way to the end. Okay. And you can have cases for whatever you want. Case 7, case 6, all that's in the book. Okay. You can also have at the end, if you need it, a default. Okay, so the default happens here at the end. And it's basically, and you don't always need that. It's saying if no other category was hit, we're going to hit that one. Okay. You have to be careful with these and you put them in the right order. And the best way to think of that, if you've ever seen a coin sorter where the coin comes down a little chute, it's going to hit different holes. Okay. Your switch statement is going to take the first case that's true. Okay, so you want to make sure. So if I had something with a case being greater than 7 and then greater than 8, greater than 9, it wouldn't work that way because they're always that way. Okay, so if you're doing that little coin sorter, the first hole can't be the quarter or everything's a quarter. Okay, so you have to make sure that you put these and test them through on paper to make sure you're getting the right case, and because it's going to hit the first one. Because some things may have they may hit more than one box. Okay. And again, there's a picture in the book on how that works with the UML activity diagram. Okay. 5.7 has a pretty good example on the auto policy case study. The case studies are big. It's worth looking through, especially if you have any questions on things. Okay. Then we have 5.8 is on the break, which we just used. A break can be used in a while, a for, a do while, or a switch. Okay. So a while, a for loop, a do while, and a switch. And what it does, again, we've got whatever structure we have. Here's our block, beginning and end. When we hit a break, it's going to go to the next line below it. Breaks you out of that structure. Okay. We also have a continue. The continue only works for a while and for a do while. And what those do, what a continue does, says go to the next iteration. Don't break out. Okay, so if we're in a while loop, while some condition statement, then if some other condition, we're going to break. I'm sorry, continue. And then we go on to do some other stuff. Okay. A break would take us down to there, but the continue takes us back up to the next loop. Okay. So that's the difference between break and continue. Okay. So we also have the ideological operators. And those start with the 2 ampersands, which is a logical and. The 2 vertical bars is a logical or. So with those, they do what we call a shortcut evaluation. Okay, so if you say something like if A is greater than 5 and B is greater than 100. Okay, with the double and, if this is false, it doesn't look at anything else. Okay, there's another version of these that have the single ones that don't do the shortcut. So then this would be evaluated, because sometimes over here you'll have some operation that you need. You don't see that too often, but sometimes you do. Okay. The other one you see sometimes. So again, just so we're clear on and or, we can look at a truth table. So if we have 2 values, so you've got, let's say, we usually use P and Q. You've got P and Q. Okay. So those can be true, 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 false, false, true, and false, false. Those are our options, okay, for those values. Then we would say that P and Q is true only when they're both true. So it's true, false, false, false. P or Q is true except when they're both false. So that's true, 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 false. Okay. And then for, we have an exclusive or. So we say P exclusive or Q or X or Q is true only when one of them is true. Okay. So it's false here, it's false here, and it's true in these two. Okay. We can also use the exclamation point, which is a unary operator, only works on one thing. Okay. So if Q is true, then not Q is false. Just reverses that. Okay. So hopefully those notes will get you started on that chapter. Again, I encourage you to read through it. The homework's going to be posted. It's getting late tonight, so either tonight or early tomorrow, the homework will be posted for the week. Okay, and then we'll meet this week on Thursday. 7 works for me, unless someone's got a different issue. Okay, so go ahead and take a look at that stuff. I'll probably in the morning put up a homework example as well, a homework-like problem that I'm not going to assign. Okay. If you have questions, as always, make sure you text me or email me, and we'll get it straightened out.